Albert Einstein's education and early academic career. Albert Einstein is one of the most influential scientists in history. He is also one of the most famous people in history, with his name being recognized by people who know nothing about science. His contributions to physics have been amazing, and he has helped shape our understanding of the universe. Einstein was born on March 14, 1879 in Ulm, Germany. His family moved to Munich when he was a baby, and they lived there until 1894 when they moved to Italy because Einstein's father had a job offer there. Albert stayed behind with relatives for a few months before going to join his family in Italy. Einstein attended school at Aargau Cantonal School for 2 years before moving back to Munich so that he could attend Luitpold Gymnasium. In 1903, Einstein graduated from high school and enrolled in the Swiss Federal Polytechnic School in Zurich to study engineering. When he was 18 years old, Einstein published 5 papers that were considered to be so groundbreaking and revolutionary that he was awarded the Nobel Prize in Physics in 1921. The groundbreaking papers included his infamous Annus Mirabilis papers, which were published on November 25, 1905, when he was only 23 years old. In 1905, Einstein made what he called the renunciation of the theory of electrons. Based on his modified version of Maxwell's theory that he called the mass-energy equivalence principle. He was also the first to propose that light sometimes behaves like a particle, and sometimes like a wave. In 1905, Einstein did not have any ideas on what is happening in black holes. The following year, at age 26, he proposed his generalized theory of relativity theory after many years of noodling around with math on the train. This was in response to some puzzling results obtained by physicist Friedmann, where a cubic centimeter of space was found to bulge outwards with a constant acceleration, even when no mass is present. Einstein's general theory of relativity predicted that an accelerated observer would see the universe as being non-Euclidean in shape. His theory also predicts black holes and wormholes. The following idea was proposed by Hawking. A black hole is a region of spacetime from which nothing, not even light, can escape. This is what happens when an object falls into a black hole. It contracts the space around it and its mass increases. Massive objects like neutron stars and black holes have to have extra space outside their surface because of the extra mass they have. This is what gives them the spherical shape. Einstein's methodology and approach to physics. Einstein's methodology and approach to physics were revolutionary. He was the first person to think of the idea that space and time are not fixed but are relative. His work on general relativity is one of the most influential scientific works in history. Einstein believed in a unified field theory which he never found. However, he did believe that there was a connection between quantum mechanics and gravity, which has been proven true with his prediction of gravitational waves, something he didn't live to see. Albert Einstein's contribution to theoretical physics has been enormous. Einstein was a theoretical physicist and philosopher who is best known in popular culture for his mass-energy equivalence formula E equals mc2. He was instrumental in the development of the theory of relativity, an important step in the development of modern physics. Einstein's 1905 paper on special relativity he published early in the year was the key philosophical step, which removed the concept of an ether and is generally seen as his most important contribution to theoretical physics. Albert Einstein, 1879–1955, German theoretical physicist, Nobel Prize in Physics 1921 for his services to theoretical physics, and especially for his discovery of the law of the photoelectric effect, the theory of relativity. The theory of relativity put forth that the law of gravity does not hold true in a vacuum, when there is no force. This is what allows objects to float on water. The theory of relativity also says that time is the fourth dimension. How did Albert Einstein influence physics? Albert Einstein is one of the most influential physicists of all time. He made many contributions to physics and his work has been highly recognized in the field. Einstein contributed to the quantum theory, general relativity, and statistical mechanics. His contributions are so significant that he has been called the father of modern physics. The 3 most important contributions Einstein made to physics and Nobel Prize winning achievements include: 1. The general theory of relativity. 2. Quantum theory. 3. Statistical mechanics. In 1907, Einstein published the special theory of relativity, which introduced his famous equation for conservation of energy and momentum P equals mv plus 0, which asserts that the energy and momentum of an object in motion are constant. The theory of relativity is all about the idea that time and space are relative, depending on how you view them. Einstein went on to present his theory of gravity in 1915, which was a best-selling book that helped him secure the Nobel Prize in 1921. In 1925, Einstein published his theory of relativity alongside Niels Bohr, one of the most important figures in 20th-century physics. The two men, who have been dubbed the fathers of quantum mechanics, came up with a model that would help explain the unexplainable, quantum theory. It's impossible to predict what will happen in any experiment, because any outcome is going to be affected by chance. Some events may happen as anticipated while others may turn out differently depending on the observer's state of mind. The theory helped to move science forward, with the discovery of the bright line between atoms, which is revealed when electrons are allowed to pass through. By the 1940s, atomic energy had been harnessed for powering nuclear weapons with a radioactive substance known as plutonium. Scientists found that uranium could be used in a similar way. In 1942, Enrico Fermi's team in Chicago conducted the first artificial self-sustaining nuclear chain reaction. Bohr's theory was based on assumptions that could not be substantiated by experiment. There were no other contradictory theories at the time, and it became widely accepted because of its simplicity and explanatory power. While later refutations would have to wait until new ideas made it possible. The Bohr model also portrays electrons as moving around the nucleus in a circular orbit, which formed the basis of quantum mechanics, and as such is still used today. The Bohr model has a fundamental flaw in that it cannot explain the stability of the atom, and as such was replaced by quantum mechanics. The concept of electrons orbiting the nucleus is not even strictly correct according to all current scientific knowledge. The Bohr model was superseded by quantum mechanics, which postulates that electrons exist only in discrete energy levels or orbits. For example, the region of space closest to the nucleus is designated as the z-orbit, and the region furthest away is the p-orbit. The quantum theory gives us a structure of energy levels used by electrons that can be explained in terms of discrete orbits. The Bohr model was replaced with a much more powerful and accurate understanding of how electrons behave. The quantum theory gives us a structure of energy levels used by electrons. The quantum theory is actually a less restrictive picture than Bohr's, in that it does not state that electrons can only move between the orbits of definite energies. All the orbitals mentioned by Bohr are now understood to exist as a continuum, and are still designated by letters from S to P. Stay tuned for part 2 of How Did Albert Einstein Revolutionize Physics, and don't forget to subscribe to my channel please. Thank you.